All right, so an inflection is a point on the graph of a function where the function is continuous and the concavity changes from upward to downward or from downward to upward, like we saw in our last example. Now, for the concavity to change at a point, f double prime must change signs at that point. So theorem one says inflection points, if from C to f of C is an inflection point of f, then C is a partition number for f double prime of, for the second derivative, basically. So if f is continuous at a partition number C of f double prime of x and f double prime exists on both sides of the sign chart of f double prime or the second derivative of f can be used to determine whether the point C f of C is an inflection point or not. So how do we test for this? So we test for inflection point by find all partition numbers C for the second derivative such that f is continuous at C. Then for each of these partition numbers C, construct a sign chart, kind of like we've done before, for f double prime x equals C. Now, if the sign chart f double prime changes at C, then the C f of C is an inflection point of f. And if the sign chart does not change at C, there is no inflection point, and therefore it's not going to change from upward to downward as far as your concavity. So if f prime of C exists and f double prime of C changes signs at x equals C, then the tangent line at the inflection point will always lie below the graph on the side that is concave upward and above the graph on the side that is concave downward. So we see that it's below the graph on the part that's concave up and it's above the graph on the part that's concave down. So that's kind of our point of inflection. Here, our point of inflection, we have it's going concave down, so it's above. Here it's concave up, so it's below. Here again, now that we have a horizontal one, so now we have it's concave up, followed by concave down, and it's below here and above here. Now this one, it's not defined because this is going to be a vertical, and so that's not going to be defined, and so that one is still it's concave down, then it concaves up, but that doesn't exist. And so we have that it's not defined at that point. But here we have those are points, partition numbers that work, okay? So that's going to be kind of the different things. And so that's kind of how we're going to see that. And so what we're going to do now is we're going to find the inflection point of this example here. So what do we need to do? Well, first off, we need to start finding derivatives and second derivatives. So what's our first derivative? Well, that's going to be what? 3x squared minus 18x plus 24. Now, our second derivative is we're just taking the derivative of our first derivative. So now that's going to be what? Well, that's going to be 6x minus 18. Okay. So now what we need to do is we need to look at that 6x minus 18, set that equal to 0, kind of to find our partition numbers. Well, if we take 18 over, we have 6x equals 18, so x is equal to 3, and that's going to be a partition number, okay? So we have our partition number is 3. That's going to be a 0, and so let's choose, we don't have to have a negative 2. Let's just choose a 2, and let's choose a 4. Okay, so if we plug in 2 here, what do we get? Well, if we plug in a 2, we're going to get a 12 minus 18, and that's going to be, if we plug it in at this point, it's going to be a 0, or it's going to be a negative, it's going to be less than 0. And so these are going to be negatives here. And if we plug in a 4, that's going to be 24 minus 18, so that's going to be a positive. So that's going to be that. And so here it's going to be concave down. Here this is going to be concave up. And so we're switching from concave down to concave up. I don't know what it's going to look like, but it's going to have some kind of a, concave up, down. Well, can't draw. Let's draw that again. So it's going to be concave down followed by concave up. Again, it's not going to be what it really looks like. It's because we have to really have a cubic. And a cubic usually, is something like this. It's going to do some weird going opposite directions. And so, but we know at 3, that's where it's going to have a point of inflection. Okay, so wherever that point is. And so the point of inflection here is at 3. And if we have 3, what is that going to be? Well, we plug all that in and we find out if we plug in 3 into that equation, it's going to be at 3, 8. Okay. So that's where our point of inflection is, where it changes signs. And so that's how we get our point of inflection. Now let's stop there and we'll come back with more.